Solar flares, geomagnetic storms. Movies and AI-generated social media posts say that they could mean the end of the world. But are the concerns right? Could a massive solar flare really send us back to the Stone Age? What would actually happen to our technology? What's the history of Earth's solar storms? Could a superflare really be in our future? And why, for the past 2 years, have the northern lights lit up skies around the world? Skies that aren't so northern at all. Join me as we unravel these questions and much, much more and enter the Codex Legendarium. I'm Shelby Melanson.
Years ago, the students of William Dawes Elementary imagined what the future might hold.
Spring 2009. I had the genius idea to go see the movie Knowing in theaters. Now, this film is a sci-fi thriller, but believe me when I tell you, I would have called it a horror film at the time. The movie is essentially about a letter pulled out of a time capsule written by a girl guided by prophetic voices that essentially predict horrible disasters and, spoiler alert, the deaths of what the movie calls EE, or everyone else. In other words, an extinction-level event, the end of the world. The method of choice for ultimate destruction? An enormous solar flare, one strong enough to eradicate Earth's protecting atmosphere, vaporize Manhattan, and send waves of fire to engulf the entire planet. This movie did a number on me when I was young, but how much did it actually get right? Okay, so first, what is a geomagnetic storm? A quick astronomy lesson here. Our sun is essentially a gigantic nuclear fusion reactor, 109 times bigger than the Earth.
The sun is a mass of incandescent gas, a gigantic nuclear furnace.
Nuclear fusion works by smashing particles of hydrogen into each other. And not only do they create light and heat that get blasted off into the space as solar wind, they also generate intense and erratic magnetic fields. You can think of this like extreme bedhead where all your hair sticks up in all kinds of directions. Sometimes, those magnetic fields get so big and so tangled that large chunks of them break off. And sometimes, that energy flies right for us. This energy comes out in 3 different ways. The first is radiation storms, or flurries of radiation particles that get basically high-speed blasted out into the rest of space. The second are coronal mass ejections, essentially giant, slow-moving clouds of solar energy. They drift over from the sun to the Earth in anywhere from 15 hours to a few days. And they're also what cause the beautiful northern and southern lights. The third and most infamous are solar flares, powerful, blindingly bright beams of energy and light that erupt from the solar surface. Records of solar events have a long history. So before we talk about what solar flares could do to our little blue planet, let's talk about what they've already done. Our sun has magnetic poles just like we have here on Earth. And approximately every 11 years, those poles actually switch places. The flip makes solar activity go crazy. And it's a time called solar maximum, which means more sunspots and stronger geomagnetic storms. NASA and other space agencies declared that the sun entered solar maximum on October 15th, 2024, and that it would continue for a year or more after that. Just before that, we found out why. On May 10th, 2024, we clocked an extremely powerful G5 storm, the strongest class of solar storms. Here's a photo I took the next day of sunspot AR3664, the source of the storm and an area 15 times the diameter of Earth. They named it the Gannon storm. And no, that's not a Zelda reference. It was named to honor the memory of leading space weather physicist Jennifer Gannon. It was the first ever G5 storm in more than 2 decades since 2003. And the result? Just like 2003, high-voltage power lines overloaded and tripped circuit breakers. Power grid transformers overheated. Satellites got knocked out of low Earth orbit. And in the Midwestern United States, GPS navigation guidance failed, and tractors and farm equipment started taking wrong turns and swerving side to side across fields of crops. It cost farmers $500 million in damages, according to just one study. In the sky, the northern lights became visible as far south as the Florida Keys, dazzling skywatchers across the US and Europe, and becoming the first time for many people to ever see the lights in person. Again, here's my shot taken from Long Island, New York. But little did we know, the Gannon storm was just the beginning. A few months later, on October 10, 2024, another powerful G5 storm blasted us with solar material, blacking out radio transmissions under 30 megahertz across Asia, Australia, and the Pacific, and lighting up the skies with northern lights as far south as a cruise ship off the coast of Cuba. Here's what it looked like through my camera lens in New York's Hudson Valley. Just over a year later, on November 11th and 12th, yet another G5 storm lit up the skies with aurora down in Florida's Space Coast and Mexico, and it shut down high-frequency radio transmissions across Africa and Europe. These storms were all brought on by X-class solar flares, the most powerful and the ones with the potential to impact technology. That is the part that got headlines, really. How big of a threat are solar flares to our technology, really? To answer that, we have to go back 166 years to the most powerful geomagnetic storm ever recorded. It's September 1st, 1859, on the outskirts of London. That morning, passionate amateur astronomer Richard Carrington opened the dome of his small, private observatory and peered at the sun through his brass telescope. What he saw shocked him. A series of gigantic dark patches had appeared on the solar surface. Just moments later, he watched as the world's biggest solar storm unraveled before his eyes. It started with what he called, quote, two patches of intensely bright and white light burst out from the sunspots. They dimmed within just a few minutes, but those flares had just released the energy of 10 billion atomic bombs. That night, just hours later, the globe's most cutting-edge technology at the time, the telegraph, went dark. Telegraph machines erupted with sparks, setting papers on fire, giving machine operators electric shocks, and causing damage to power grids. Outside, brilliant auroras lit up the skies as far south as Cuba and Hawaii. They were so bright that birds actually started chirping in the middle of the night, and at least one report said it even fooled people into thinking it was morning and starting their workday. As striking as the Carrington event was, it's not one of a kind. Decades later, on May 15, 1921, another solar event called the New York Railroad Storm knocked out the entire switchboard and operations system of what was then called New York City's Central Railroad, all below 125th Street in Manhattan. A control tower on 57th Street and Park Avenue caught fire, and so did at least one telegraph machine. Other reports say that fire spread to the entire building. And across the pond, most telephone and telegraph communication was shut down across Europe. And a Swedish telephone station also caught on fire. A study from 2019 actually speculates this storm might have been on par with the strength of the Carrington event. Skipping forward, a 1989 storm knocked out power for the entire Canadian province of Quebec. And as recently as 2012, we quietly dodged a celestial bullet. That's when the biggest CME, or Coronal Mass Ejection, since the Carrington event narrowly missed Earth because the sunspot it came from was just slightly pointed away from us. You probably didn't hear about any of this, but according to Daniel Baker of the University of Colorado, quote, if it had hit, we would still be picking up the pieces 2 years later. What if these storms were still just the beginning? In 2012, scientists at Japan's Nagoya University discovered evidence of an ancient solar storm, anywhere from 10 to 100 times more powerful than the Carrington event. It happened around the year 775 AD, or about 1200 years ago. The current theory is that the storm was caused by a once in 10,000 years superflare, a solar ejection thousands of times more powerful than the ones we see today. Here's the thing, we found evidence of 5 more since then, going back as early as over 14,000 years ago to just over 1,000 years ago. To put that in perspective, this happened around the same time as the Holy Roman Empire and when the Viking Leif Erikson arrived in North America. We can tell these storms, called Miyake events by the way, happened by doing chemical analysis on samples of polar ice caps and also the rings of very, very old trees. Bursts of solar radiation on Earth cause unusually large layers of radioactive carbon isotopes to get trapped in these materials. Scientists can then date them and look for similar samples from other places around the same time to verify the existence of the superflare. And in the case of that 775 AD solar storm, trees from Germany, Russia, the United States, Finland, and New Zealand all told the same story. Going back to what Richard Carrington saw, the world was a very different place back in 1859. The telegraph was a novelty that only trained operators ever came into direct contact with. That's a far cry from today, where most of us measure our daily screen time in hours. Not only are our phones and computers everywhere, most of our cars, home appliances, and systems and bank accounts are all digital. Plus, the small matter of, say, the global financial system and military gear and communication. So, if we did witness another Carrington event, or even worse, what would actually happen? We already know geomagnetic storms can cause blackouts and damage to electrical grids, meaning a supersolar event could make history's biggest blackouts basically look like child's play. However, we have an advantage. In most cases, astronomers can predict ahead of time when a solar flare or a CME will hit Earth. That means power grid operators can make adjustments so the system doesn't get overloaded. In extreme cases, power grids could even be temporarily turned off to avoid damage. That said, once in a while, solar events can actually sneak up on us. Increased levels of solar wind make it near impossible for satellites or coronagraphs to see when a geomagnetic storm is brewing. We saw this happen just as recently as November 20th. Speaking of satellites, strong solar radiation can block them from transmitting data to Earth. But a huge solar storm could actually throw them off course so much that they would literally get dragged back down to Earth and burn up on re-entry. Simulations modeled by scientists from the ESA this year showed that a big enough solar storm could effectively wipe out all satellites. And as those go down, GPS and cellular service, aka phone calls, would go with them. Global air traffic would get grounded too. And a study from 2013 found that a Carrington-level event could cost the North American power grid alone $2.6 trillion in damages. Likewise, the Planetary Society wrote that the true cost would be, quote, beyond the scale of our comprehension. Here's why. A massive amount of solar energy could also short out large electronics on a mass scale. Imagine if most large tech objects spontaneously shut down, started spitting out sparks, and catching fire. What if those fires spread to entire buildings? The most extreme theories and worst-case scenarios on this suggest that mass fire outbreaks would overwhelm first responders around the world. Damages could be so extreme they would take weeks, months, or even years to repair. And while we're talking worst-case scenarios here, what if this happened during or just before winter, when much of the globe depends on electrical heating in order to keep warm? It gets even bigger. Widespread, long-term blackouts and failed satellites. That means no internet, no tech. How many of your daily necessities do you access through your phone? Forget about TikTok, how about your bank account? And in a worst-case scenario, what if online systems like SWIFT, the network that literally powers the global financial system, went offline? Vanessa Thomas, a science writer for NASA, wrote this in 2023, quote, "Such technological chaos could cripple economies and endanger the safety and livelihoods of people worldwide." A lot of that risk could just be eliminated by flipping the master-off switch on these power transformers. But how realistic is it to power down every major technological device across the entire sunlit half of the globe? Here's the big question. How likely are we really to see another Carrington event or bigger? Well, according to experts, it's more of a when than an if. That's according to a scientist who helped run those ESA simulations we talked about earlier. Scientists believe that a Carrington-style event occurs roughly every 500 years. That translates to about a 12% chance in the next century. Although, others put the odds anywhere from a very slim 1% to a whopping 25%. So ultimately, we don't know. But the thing is, them's the breaks of living beside an enormous fusion reactor. That vaporizing Manhattan scene in the movie Knowing is probably a no-go. It's true, a Carrington-sized sunspot, AR 4294-4296, did point right at Earth in early December 2025. but it's staying quiet. And beyond that, our atmosphere is super good at soaking up solar radiation. The only plausible way for solar radiation to vaporize us would be, say, if a nearby star died by way of supernova and the explosion was close enough to blast away our entire atmosphere. Thankfully, there are no stars close enough for that, and also, without an atmosphere, we'd have bigger concerns anyway. So, will a monster flare end the world? Probably not. Though, in theory, a superflare could send us back to the pre-tech days of the 1800s. Our sun makes life here possible. It's our source of life energy, and with every great gift from the universe comes risk. If you ask me, that's part of the balance of the universe. Whether you look at it as a form of Newton's third law, every action has an equal and opposite reaction, or more of the God giveth and God taketh away perspective, I personally like this quote from the author Kristen Harmel, quote, "The universe is always in balance, summer and winter, day and night, sustenance and poison, good and evil. To know the light, you must also know the darkness." What do you think? Did the movies take too much artistic liberty or portray legitimate danger? How do you think we should be preparing for a possible solar event, if at all? I'd love to hear your thoughts in the comments, and if you have an idea for something you'd like to see a future episode on, let me know. And of course, if you enjoyed this deep dive into mysteries, myths, culture, and science, please take a second to like and share this video, and if you want to see more, subscribe. It really, really helps get the word out about the show. Until next time, stay curious. Thank you.